Welcome to our exploration of the fascinating history of language models. In this video, we'll journey through time to uncover how language models have evolved from simple beginnings to the advanced systems we use today. Language models are at the heart of many technologies, powering everything from search engines to virtual assistants. By understanding their history, we gain insight into how they shape our daily lives and what the future might hold. Let's start by looking at the earliest attempts to teach machines how to understand and generate human language. Roots of language models can be traced back to the early days of computational linguistics in the 1950s. Researchers began experimenting with ways to process and analyze human language using computers. These early efforts focused on simple rule-based systems, where computers followed predefined instructions to interpret text. While limited in scope, these pioneering projects laid the groundwork for future advancement. The idea that machines could understand language was revolutionary, sparking curiosity and further research in the field. The 1960s and 1970s, rule-based language models became the standard approach. These systems relied on handcrafted rules created by linguists and programmers. For example, early machine translation systems attempted to convert sentences from one language to another by following strict grammatical rules. While these models could handle simple sentences, they struggled with the complexity and ambiguity of natural language. Despite their limitations, rule-based models were a crucial step in the evolution of language technology. 1980s marked a turning point with the introduction of statistical methods. Instead of relying solely on rules, researchers began using probability and statistics to model language. This shift allowed computers to learn patterns from large collections of text, making language models more flexible and robust. Statistical models could handle a wider range of language inputs and adapt to new data, paving the way for more sophisticated applications in speech recognition and translation. One of the most influential statistical models was the N-gram model. N-gram models predict the next word in a sequence based on the previous N1 words. For example, in the phrase, "the cat sat on the," an N-gram model would use the preceding words to guess what comes next. These models became the backbone of many language processing systems, offering a simple yet effective way to capture language patterns. However, they still had limitations, especially with longer context. As computing power increased in the 1990s and 2000s, machine learning techniques began to dominate the field of language modeling. Instead of manually crafting rules or relying solely on statistics, researchers trained algorithms to automatically learn language patterns from vast datasets. This era saw the emergence of more accurate and adaptable models, capable of handling complex language tasks such as speech recognition, sentiment analysis, and information retrieval. Introduction of neural networks marked a significant leap forward. Neural networks are inspired by the human brain and can learn intricate relationships in data. In language modeling, they enable computers to understand context and meaning at a much deeper level. Early neural network models, such as feed-forward and recurrent neural networks, outperformed traditional statistical models and opened the door to even more advanced techniques. Current neural networks, or RNNs, became popular for their ability to process sequences of data such as sentences or paragraphs. Unlike earlier models, RNNs could remember previous words in a sequence, making them ideal for language tasks that require context. This innovation led to significant improvements in machine translation, speech recognition, and text generation, bringing us closer to natural-sounding machine language. To address the limitations of standard RNNs, researchers developed long short-term memory networks, or LSTMs. LSTMs are a special type of RNN designed to remember information over longer sequences. This made them especially useful for tasks like language translation and speech recognition, where understanding context over many words is crucial. LSTMs quickly became a standard tool in the language modeling toolkit. Major breakthrough came with the introduction of the attention mechanism. Attention allows models to focus on specific parts of a sentence when making predictions, much like how humans pay attention to important words. This concept revolutionized language modeling, enabling more accurate translations and better understanding of complex sentences. Attention paved the way for the next generation of language models. 2017, the introduction of the transformer architecture marked a turning point in language modeling. Transformers use self-attention mechanisms to process entire sentences at once, rather than word by word. This innovation led to dramatic improvements in performance and efficiency, making it possible to train much larger and more powerful language models. Transformers quickly became the foundation for state-of-the-art systems. With the rise of transformers, researchers began pre-training language models on massive datasets before fine-tuning them for specific tasks. This approach, known as transfer learning, allowed models to develop a broad understanding of language that could be adapted to a wide range of applications. Pre-trained models like BERT and GPT set new benchmarks in natural language processing. ERT, or bidirectional encoder representations from transformers, was a groundbreaking model introduced by Google in 2018. Unlike previous models, BERT reads text in both directions, allowing it to understand context more deeply. This bidirectional approach led to significant improvements in tasks like question answering and sentiment analysis, making BERT a cornerstone of modern language technology. OpenAI's GPT series took language modeling to new heights. GPT models are trained to generate human-like text, making them incredibly versatile for tasks such as writing, summarization, and conversation. Each new version of GPT has grown in size and capability, demonstrating the power of large-scale pre-training and the potential for creative language generation. As language models became more successful, researchers began scaling them up, training ever larger models on vast amounts of data. This scaling led to dramatic improvements in performance, but also raised new challenges, such as the need for more computing power and concerns about bias and fairness. The trend toward larger models continues to shape the field today. Today, language models are everywhere. They power virtual assistants, help us write emails, translate languages, and even generate creative content. From smartphones to smart speakers, these models have become an integral part of our daily routines. Their ability to understand and generate language has transformed the way we interact with technology and each other. Search engines rely heavily on language models to understand queries and deliver relevant results. By analyzing the intent behind our words, these models help us find information quickly and accurately. Advances in language modeling have made search engines smarter and more intuitive, improving our ability to access knowledge online. Virtual assistants like Siri, Alexa, and Google Assistant use advanced language models to interpret our commands and respond naturally. Chatbots in customer service and online platforms also rely on these models to provide helpful and conversational interactions. The progress in language modeling has made these digital helpers more accurate and user-friendly. Language models have revolutionized machine translation, making it possible to translate text between languages with remarkable accuracy. Modern translation systems use deep learning and attention mechanisms to capture the nuances of meaning and context, enabling smoother communication across cultures and borders. One of the most exciting applications of language models is text generation. From composing poetry to drafting news articles, these models can produce creative and coherent writing. They are even being used to assist authors and journalists, opening up new possibilities for human-machine collaboration in creative fields. Language models have played a key role in advancing speech recognition technology. By understanding spoken language, these models enable voice-controlled devices, transcription services, and accessibility tools for people with disabilities. The accuracy and reliability of speech recognition have improved dramatically thanks to modern language modeling techniques. Businesses and organizations use language models to analyze customer feedback, reviews, and social media posts. Sentiment analysis helps them understand public opinion, track trends, and make informed decisions. By detecting positive, negative, or neutral sentiments, language models provide valuable insights into how people feel about products and services. Modern language models excel at summarizing long documents and extracting key information. This capability is invaluable for researchers, journalists, and professionals who need to process large volumes of text quickly. Automated summarization tools save time and help users focus on the most important points. As language models become more powerful, ethical considerations have come to the forefront. Issues such as bias, misinformation, and privacy are critical challenges that researchers and developers must address. Ensuring that language models are fair, transparent, and accountable is essential for building trust and promoting responsible use. Language models can inadvertently learn and amplify biases present in their training data. This can lead to unfair or discriminatory outcomes in applications like hearing, lending, or law enforcement. Researchers are actively working on methods to detect and mitigate bias, ensuring that language models serve all users equitably. With language models processing vast amounts of personal data, privacy and security are major concerns. Protecting user information and preventing unauthorized access are top priorities for developers. Techniques such as data anonymization and secure model deployment help safeguard sensitive information. Language models can be used to generate convincing but false information. Combating misinformation is a growing challenge, requiring careful monitoring and the development of tools to detect and prevent the spread of fake news. Responsible use and oversight are essential to ensure that language models are used for good. The open source movement has played a significant role in the development of language models. By making code and models freely available, researchers and developers can collaborate, share knowledge, and accelerate progress. Open source projects like Hugging Face have democratized access to powerful language technologies. Recent advances have led to the creation of multilingual language models capable of understanding and generating text in multiple languages. These models break down language barriers and enable global communication, supporting users from diverse linguistic backgrounds. In addition to general-purpose models, researchers have developed domain-specific language models tailored for fields like medicine, law, and finance. These specialized models are trained on industry-specific data, enabling them to provide expert-level insights and support for professionals. Modern language models are capable of few-shot and zero-shot learning, meaning they can perform new tasks with little or no additional training. This flexibility allows them to adapt quickly to new challenges and applications, making them even more powerful and versatile. Interactive AI systems such as chatbots and conversational agents rely on advanced language models to engage users in natural dialogue. These systems are becoming increasingly sophisticated, capable of understanding context, managing multi-turn conversations, and providing personalized responses. Language models can be fine-tuned to reflect individual preferences and styles, enabling personalized experiences in applications like writing assistants and recommendation systems. Customization ensures that users receive relevant and engaging content tailored to their needs. Advances in hardware and software have enabled real-time language processing, allowing applications to respond instantly to user input. This capability is essential for interactive systems, live translation, and voice-controlled devices, making technology more responsive and accessible. Language models are increasingly being integrated with other technologies such as computer vision, robotics, and the Internet of Things. This integration enables new applications from smart home devices to autonomous vehicles, expanding the impact of language modeling beyond text. While large-scale language models offer impressive capabilities, they also present significant challenges. Training and deploying these models require enormous computational resources, raising concerns about energy consumption and environmental impact. Researchers are exploring ways to make language models more efficient and sustainable. As language models become more influential, governments and organizations are developing regulations and guidelines to ensure their responsible use. Issues such as transparency, accountability, and ethical standards are central to these efforts, shaping the future of language technology. The future of language modeling is full of exciting possibilities. Researchers are exploring new architectures, training methods, and applications that could further enhance the capabilities of language models. Ongoing innovation promises to make these systems even more powerful, adaptable, and beneficial to society. Language models are increasingly being used as collaborative tools, assisting humans in creative, analytical, and decision-making tasks. By working together, humans and AI can achieve results that neither could accomplish alone, opening up new frontiers in productivity and innovation. Language models are transforming education by providing personalized tutoring, automated grading, and language learning support. These tools help students learn more effectively and give educators new ways to engage with learners, making education more accessible and inclusive. In healthcare, language models assist with tasks such as medical record analysis, patient communication, and diagnostic support. By processing vast amounts of medical data, these models help healthcare professionals make better decisions and improve patient outcomes. Language models are making technology more accessible for people with disabilities. From real-time transcription for the hearing impaired to text-to-speech for the visually impaired, these tools are breaking down barriers and promoting digital inclusion. Artists, musicians, and filmmakers are using language models to generate lyrics, scripts, and even entire stories. These creative collaborations are pushing the boundaries of art and entertainment, demonstrating the versatility and potential of language technology. The field of language modeling is constantly evolving, with researchers exploring new ideas and pushing the limits of what's possible. From improving model efficiency to enhancing interpretability, ongoing research ensures that language models continue to advance and benefit society. History of language models is a story of innovation, collaboration, and discovery. From humble beginnings to cutting-edge AI, language models have transformed the way we communicate, learn, and create. As we look to the future, the journey of language modeling continues, promising even greater advancements and opportunities for all.